What if AI could improve itself by rewriting its own code? In this video, let's look at this interesting research work from Sakana AI termed as the Darwin Gödel Machine. So the idea over here is that can you create a coding agent which can rewrite its own code and improve itself? So the long-standing goal of AI research has been the creation of AI that can learn indefinitely. So this is what is known as meta-learning, the concept of learning to learn, which aims to create systems that not only solve problems but also evolve their problem-solving strategies over time. So one of the most ambitious efforts in this direction is the Gödel machine, proposed by Jürgen Schimdhuber decades ago and was named after the famous mathematician Kurt Gödel. So a Gödel machine is a hypothetical self-improving AI system that optimally solves problems by recursively rewriting its own code when it can mathematically prove a better strategy. So it represents the ultimate form of self-awareness in AI, an agent that can reason about its own limitations and modify itself accordingly. So here there is this thing that it can mathematically prove a better strategy. So that is where what Sakana AI researchers have come up with is, let's relax that, mathematically proving that it can improve itself, but let's look at it from a practical point of view, whereby we can create a coding agent, we can evaluate the coding agent on a benchmark, and if it improves on the benchmark, that means that it is improving. So that is one idea. The next idea is that how can you actually do this Darwinian exploration? So if you see in the Darwin Gödel Machine, so what is this Darwinian exploration? So for this, what they do over here is that, they create a initial agent, or they have an agent archive. So they have multiple coding agents over there, or you can take an initial coding agent. Then from that agent, they do some kind of parent agent self-modification step to create a child agent. Now that child agent can be evaluated on a benchmark, and if it is good, it can be added to the tree over here, the evolutionary tree. So that is the idea behind Darwin Gödel Machine. It's a self-improving coding agent that rewrites its own code to improve performance on programming tasks. It creates various self-improvements such as patch validation step, better file viewing, enhanced editing tools, generating and ranking multiple solutions to choose the best one, and adding a history of what has been tried before, why it has failed when making new changes. So in this way, it keeps improving itself. So that is the idea over here in the Darwin Gödel machine. Now what are the steps in the Darwin Gödel machine? So how do you implement this, or how does it work? So the general workflow is like this. You have an initialization. So evolution begins with one or a few basic coding agents, so called seeds of intelligence. So this forms an archive of agents for the DGM, or the Darwin Gödel machine, or this functions like a biological gene bank. So this archive preserves all previously generated agents regardless of their performance level, ensuring that no potentially valuable variation is permanently lost. Then there is sampling. So DGM selects one or more parent agents from the archive to generate new child agent. The selection mechanism does not focus solely on top performers, but instead allows every agent a chance to be chosen. While higher performing agents are most likely to be selected, DGM also encourages exploration by giving less successful agents an opportunity to contribute to future generation. Then you have reproduction, which is actually creating the new child agent by doing modifications on the parent agent. So this could be like by enhancement of existing tools for the child agent, by addition of new tools or workflows, improvement of problem solving strategies, introduction of collaboration mechanisms, like having an agent's codes reviewed by another before execution. So you can create child nodes. Now this child node goes through the process of natural selection, which is about, it is being tested on a benchmark for performance, and based on the performance, it is then added to the pool, your archive pool, and in this way you can also create that tree. If a child agent outperforms its parent or meets certain quality thresholds, it is added as to the archive and becomes a new node in the evolutionary tree. So this process repeats iteratively, creating a growing structure of diverse high quality agents. And DGM also enables parallel exploration of many different paths in the search space, promoting open-ended discovery and avoiding premature convergence to local optima. So this is how you have this Darwin Gödel machine coming up. So you have this open-ended exploration of self-improving agents by creating these evolutionary tree of agents. Now this coding agent makes use of an LLM internally, right, to write code. And what they are saying over here is that by this open-ended exploration of your search space, this overcomes traditional hill climbing methods which can often get stuck in local optima. Because DGM employs open-ended exploration, this approach allows even underperforming agents to persist if they contain novel ideas that may lead to breakthroughs in future generations. So this is something which they have observed in their testing as well, in their experiment also. So in the SW bench experiment, what they're saying that the performance of a newly generated agent showed temporary declines in the 4th and 56th iterations, but by the 70th iteration, they had created an agent that surpassed all their predecessors. So that is why this open-ended exploration is helping over here when compared to traditional hill climbing methods. Okay, so the authors evaluated DGM on two challenging benchmarks: SW bench, a widely used benchmark that tests agents' ability to resolve real-world GitHub issues. DGM showed impressive progress over here, improving its performance from 20 to 50% through self-modification. Then the other one is Polyglot, which is a multi-language coding benchmark containing coding problems in C++, Go, Java, JavaScript, Python, and Rust. Here also DGM achieved even more dramatic improvement, jumping from an initial 14.2 to 30.7 success rate, far surpassing the representative hand-designed agent by Aider. So this is what they are claiming over here, and what they are saying is that through ablation studies, if you remove the self-improve step, then the performance declined substantially. Even if you remove this open-ended exploration Darwin step, again it kind of resulted in lower performance. So both are necessary over here for the success of DGM. Okay, that is the idea over here. Now you also have AlphaEvolve from Google, which was developed by Google DeepMind, which also has similarly your AI improving itself to solve problems, and it already proved itself in real world impact problems like data center efficiency, AI acceleration, mathematical breakthroughs. But what is the difference between AlphaEvolve and DGM? So the focus of AlphaEvolve is evolving function and code bases. DGM is evolving the agent itself. Level of innovation is at algorithmic level. AlphaEvolve was trying to improve algorithms, whereas DGM is at agent level. Okay. Role of LLM in AlphaEvolve: LLM acts as genetic operators to modify algorithms. Here LLM serves as a brain to evolve itself with better tools and strategies. Here you have open-ended environments for evaluation. Here you have well-defined problems with automated evaluators. So here is an interesting analogy between these two approaches. So if you have two chefs working in different kitchens, AlphaEvolve is like a highly skilled chef who follows and refines recipes for specific dishes. He uses an AI-powered assistant to suggest variations such as substituting ingredients or adjusting cooking times to make the dish better. Every new dish version of the recipe is taste tested by an automated panel that rates flavor, texture, and presentation. If it scores high, the new recipe becomes the standard. If not, it is discarded. So this is AlphaEvolve, right? DGM, on the other hand, is more like a chef who constantly improves his own culinary skills and kitchen tools, not just the recipes. He does not just tweak ingredients, but rather learns new techniques, upgrades his knives, reorganizes the kitchen layout, and even teaches junior chefs. He experiments in real-world settings like hosting large dinner parties or catering events where the feedback is not always structured but is rich and varied. Over time, he becomes a better chef overall. That is the idea over here. So you can, so that is DGM. Okay. So with this analogy, you can understand the difference between AlphaEvolve and DGM. So you can read this wonderful post over here by by this author Richard, okay, so which talks about AI that can improve itself, where is given an explanation of Darwin Gödel machine as well as the comparison with AlphaEvolve. You can also read this blog to understand further about AI which can improve itself, which is the Darwin Gödel machine. So this is a short video on Darwin Gödel machine. Hope this video is useful. I'll be putting the links in the description of the video. See you in another video.